Good morning, students. Mr. Carver here. A quick supplementary video to conic sections. We need to talk about eccentricity. This comes up occasionally in conic sections. It becomes more important the deeper you get into these shapes. But eccentricity is defined as the ratio of two measurements. The numerator being the distance from the center to the focus, and the denominator being the distance from the center to the vertex. These are sometimes noted by using the variables C and A. So again, distance from center to focus over distance from center to vertex. Let me show you a quick picture here. Let's take an ellipse. Distance from center to focus obviously is this distance right here. That's going to be your C. Your A then is the distance from the center out to the vertex. And I should mention, the vertex is commonly referred to as the endpoints of the major axis for ellipses. So this part is A. So C over A in this case will be less than 1. So for an ellipse, eccentricity, and to avoid all confusion in mathematics, we'll let lowercase e stand for eccentricity. Eccentricity for an ellipse will fall between 0 and 1. Or in the case of a basketball, a hyperbola, your C now is going to go from center to either focus point. That's your value of C right there. And then again, your A will go center to vertex, either one of the vertexes. So if you put C over A, you can tell that for a hyperbola, your E will be greater than 1. Now, for a parabola, it's a little bit different. You don't have a center, obviously. So, C over A, distance from center to focus over distance from center to vertex, also is equal to PF over PD. And this is especially useful in parabolas. This is point to focus over point to directrix. Point to focus is any point on the curve to the focus point. That would be this right here. This is your PF. And then your PD is this right here. Point to directrix, the point being the vertex. And if you recall, both of those are 1 over 4a, which means C and A, or PF over PD, are equal to one another, which means for a parabola, they are equal to 1. So I could squeeze that in there, but I don't think I can write small enough. Eccentricity is equal to 1 for a parabola. And then lastly, you have a circle. And you can also actually think of a circle as being an ellipse where the two denominators are the same. So the distance from the center out to either one of the vertices is going to be identical. So in this case, your C, center to focus, is actually 0 over A. So for circles, your eccentricity is equal to 0. So you can see that eccentricity has to vary from 0 to 1, including the endpoints. If it's 0, it's a circle. Less than 1 ellipse, greater than 1 hyperbola. And if it is 1, it is a parabola. I did say that it's bound from 0 to 1. That's incorrect. If it's bigger than 1, it is a hyperbola. All right. I think that's all you need to know about eccentricity. Have a great day, guys. Thank you.